This next problem asks us to solve an exponential equation, and I happen to notice that 81 is a power of 3. So let's rewrite this as 3 to the x plus 4 power is equal to 3 to the 4th. And since I have the same base on each side, I can set my exponents to be equal to each other and then solve the equation that remains. We then have x plus 4 is equal to 4, and x is then equal to 0. Now, this next problem is essentially the one just like the one before, but instead of 81, I've got 85, and I cannot write this as a power of 3. So instead, I want to log each side. I'll have log of 3 to the x plus 4 power is equal to the log of 85. And this allows this power to now come down out in front, and we'll need to write it with parentheses. X plus 4 times the log of 3 is equal to the log of 85. Now I can either choose to distribute or just divide off the log, which is what I'm going to do. X plus 4 is going to be the log of 85 divided by the log of 3. And to solve for x, I can just subtract 4 on each side. The log of 85 divided by the log of 3, all of that minus 4. Now that is the exact answer, and when you approximate it using a calculator, you should get 0.04388. Now let's solve a logarithmic equation. I see two logs, but I've also got that negative 1 by itself. So I'm going to choose to get all the logs to one side, and I think I'm going to do that by bringing the 1 on the left to the right, so I can have negative 1 equals negative log x minus the log of x minus 9. Now I don't like all those negative signs, so I'm going to divide all the way through by negative 1 and rewrite this as 1 equals the log of x plus the log of x minus 9. Now I can use the property involving the sum of logarithms and write this as 1 equals log of x squared minus 9x. Now since I only have a log on the right hand side, the best way to clean this up is to switch it to an exponential equation. I will want to write the understood base of 10 in there and go 10 raised to the first power equals the argument. 10 to the first power is just 10 equals x squared minus 9x, and the logarithms are gone, and I can just solve this quadratic equation. Setting it equal to 0, we have 10 is equal to x squared minus 9x minus 10, which then factors into x minus 10 and x plus 1, and it appears our two solutions are 10 and negative 1. However, when you substitute negative 1 back into the original problem, you get the log of a negative, which isn't allowed, and only 10 is a viable solution. Another log problem, but this time involving natural logs. I want to get all the logs to one side, so I'll have the natural log of 21 minus the natural log of x minus 2 is equal to 1. The difference of two logs can be written as the log of their quotient, so I will have 21 over x minus 2 as the argument to the log equals 1. And then I'm going to need to put an understood base of e in and go e to the first equals what's inside that argument. So I've got e to the first is equal to 21 over x minus 2, and I'll write that as an e over 1 so that I can cross multiply. Upon cross multiplying, I'm going to have e times x minus 2 is equal to 21. I can either distribute right now or divide by e, which is a number, not a variable, remember that. And so x minus 2 is going to equal 21/8, and when you add 2 to both sides, you get 21/8 plus 2. Now that is your exact answer, and if you use a calculator to approximate it, you will find out that you get approximately 9.7255.